Good morning. So we are going to see about what about more on forward kinematics. Okay. So in this thing, what you're going to see the again, we are going to see about dynamic Hagenbeck parameters. Okay. In this maximum, we'll be seeing about how we'll be having a fun, how we'll be representing in terms of forward kinematics. Okay. So actually, this can also to be named as some DH parameters. So we'll have a four parameters. It will be associated with a particular convention for attaching reference frames to the links of a spatial kinematic chain or robot manipulator. Okay. So I said you that we'll have a four parameters. Okay. So this is the notations what you're going to use it over on it. Okay. So in this, what we'll be having of it again, so that is each area will be assigned as a coordinate frame. Okay. So actually, this Jacques Denavit and Richard Hattenbeck, so they have introduced this convention in the year of 1955 in order to standardize the coordinate frames. Okay. Um, so what they have done over on it again, uh, so commonly used conventions, which is used for selecting the frames of reference in robotics. Okay. Um, so in this convention, what they have done now, they have a coordinate frames which are attached to the joints between two links of it. One transformation is associated with the joint with it, and the second is associated with the link. Okay. So the coordinate transformations வந்து பார்த்தோம் அப்படின்னா, so will be consisting of n links. So using the derivation, we have four parameters which is described to our frame I. I வந்து related to a previous frame I minus 1. So இங்க parameters வந்து நம்ம என்னென்ன யூஸ் பண்றோம் அப்படிங்கிறது we are using notations. Okay. So for example, if you're having of an AI minus 1 அப்படிங்கிறது, so what is the technical definition which shows that அப்படின்னா, so this is the length of the perpendicular between the joint axis. So joint axis அப்படிங்கிறது, this is the axis around which revolution takes place. So in which they are to be named as an Zi minus 1 and Zi axis. Okay. So these two axes வந்து பார்த்தோம் அப்படின்னா, which can be viewed as lines in space. Okay. So the common perpendicular அப்படிங்கிறது, it is the shortest line between the two axis line and it is perpendicular to both axes. Okay. So when we are going for an visualization approach, so approach to this, we have to imagine that there is an expanding cylinder whose axis is the I minus 1 axis, and the cylinder just touches the joint axis. So the radius of cylinder வந்து என்ன பண்றோம் அப்படின்னா, which is equals to AI minus 1. Okay. So when it is usually on the diagrammatic approach method, so diagram வந்து which already specifies the various coordinate frames. So common perpendicular வந்து usually x of I minus 1 axis. So AI minus 1 அப்படிங்கிறது பார்த்தோம் அப்படின்னா, is just the displacement along the xi minus 1 to move from I minus 1 frame to the I frame. Okay. So if the link is prismatic அப்படின்னா, AI minus 1 அப்படிங்கிறது variable இருக்கும். It is not a parameter. Okay. So next I minus 1. So when you are saying about that when, so we have to define the technical definition. So it says that amount of rotation around the common perpendicular to the joint axis of parallel. So how much we have to rotate around the x axis. So that Zi minus 1 is pointing in the same direction as the Zi axis. So positive rotations வந்து பார்த்தோம் அப்படின்னா, it will follow the right hand rule. Next, third thing வந்து பார்த்தோம் அப்படின்னா, we'll have a di minus 1. This is a technical definition. We are defined that the displacement along the Zi axis is needed to align the AI minus 1, which is common perpendicular to the AI. So in other words, என்ன பண்றோம் அப்படின்னா, the displacement along the Zi வந்து will align to the xi minus 1 and xi axis. Okay. So finally, the last thing will be representing amount of rotations around the Zi axis needed to align with the xi minus 1 axis with the xy axis. So இப்போ dynamic Houghton-based matrix வந்து என்ன சொல்றோம் அப்படின்னா, so we'll have a cos theta I minus sin theta I 0, a of I minus 1, sin theta I cos of alpha I minus 1, theta I to cos minus sin minus 1, so sin and sin to cos and sin, we'll have a cos 0 0 0. So just like the homogeneous matrix என்ன பண்றோம் அப்படின்னா, the dynamic Houghton-based matrix வந்து it is a transformation matrix. So from one coordinate frame to the next. So using a series of DH matrix multiplications in the DH parameter table method, the final result is a transformation matrix from some frame to. Okay, so they are the transformations over here. So apart from that, what we'll have over here, we'll have a 3 revolute joints. So notice that we have a table has two uses. One வந்து என்ன அப்படின்னா, we can able to describe the robot with its variable and its parameters. Similarly, we can able to describe some state of the robot by having a numerical values for the variables. So I வந்து 0, 1, 2, alpha of I minus 1, I minus 1, di theta I 1, 0, 0, 0, theta naught. So similarly 0, A naught, 0, theta 1. So angle will be minus 90, A1, B1, 2, and theta 2. Similarly, the next one will have the DH matrix with I minus 1 is equal to 0 and I is equal to 1. So we'll be using the notation of P of x naught, y naught, z naught, where t is equivalent to x2, y2, z2, 1. So I வந்து 0, 1, 2, AI minus 1, so DI. So we'll have the notations over on and we will be framing the DH matrix over. Okay. So by replacing the values of theta is equivalent to 90, so we'll have a cos theta naught, theta 1 and theta 2. So the value of T naught, T1 and T2. So this is just rotation around the Z naught axis. So we'll have the rotation of cos theta naught minus sin theta naught and cos theta naught. Whereas in the case of an T1, translations will be followed by the rotation around the Z1 axis. The next thing we'll have a translation by A1 and a D2 followed by rotation around the Z1. So where T is the so translation, that is the rotation around the Z0. Next one is the translation, which is followed by the rotation, translation, and then D2 followed by the rotation. So these are all about the forward kinematics. So next thing we have to see about an inverse kinematics. So inverse kinematics, already we know that. So we will be calculating from the position to the angle. So when we are defining inverse kinematics, so it is a mathematical process of calculating the variable joint parameters which is needed to place the end of a kinematic chain. So this is the robot manipulator for an animation character, for example. So whatever it may be. So this is the inverse. So when you are saying about the use of inverse dynamics in the pattern, so it is used to determine the motion of a robot to reach a desired position. Okay. For example, if you want to perform an automated bin blocking, so robotic arm will be used in a manufacture. Okay. So between the bins and the manufacturing. Okay. So this is a way to find out the inverse kinematics of a robotic arm. So inverse kinematics அப்படின்னாலே what we can say it அப்படின்னா we can say for an reverse process. Okay. So a simple example இப்போ பார்த்தோம் அப்படின்னா we'll have a revolute and prosthetic joints combined over there. We have to find the value of something. So theta will be find out an arc of tan of y by x. So more specifically பார்த்தோம்னா 2. The 2 specifies the first quadrant. So in order to find the s வந்து என்ன பண்ணணும் அப்படின்னா square root of r x square plus a y square. So inverse kinematics of the two linked manipulator எடுத்தோம் அப்படின்னா so the given the value of an L1, L2, x and y. We have to find out the value of an thing. So redundancy என்ன பண்ணும் அப்படின்னா so unique solutions வந்து it is not exist. So note that we will be using the given two solutions are for sometimes no solutions. So geometric solutions எடுத்தோம் அப்படின்னா let me take a triangle solution. So using the laws of cosines and sines. So cosine law என்ன நமக்கு so c squared equals to a squared plus b squared minus 2abc. So cங்கிறது என்ன அப்படின்னு பார்த்தோம் அப்படின்னா so this is nothing but an x squared plus y squared. So a-ங்கிறது L1, b-ங்கிறது L2, so L1 squared L2 squared minus 2L1. So c-ங்கிறது cos of 180 minus theta. So 180 minus theta 2 minus cos theta 2. So cos theta 2 நம்ம represent பண்ணோம் அப்படின்னா x squared plus y squared minus L1 squared minus x squared by 2L1. அதுல theta 2 அப்படின்னா arc of cos. So redundant since theta 2 வந்து it can be the first of 4 to 4. அதே log of cosine sin b by 2 sin c by 2. So being with theta 1, small being with L1. Being with negative minus theta 2, look at x squared. Whereas cos வந்து minusல வரும், sin வந்து பார்த்தீங்கன்னா positive வரும். So which is equal to theta 1 plus theta 1 plus alpha arc tan 2 by 2. So redundancy cost வரும்போது since theta 2 has two possible values, so theta 1 is arc sink of L2 sin theta 2 plus arc tan 2 of theta 2. இதோட algebraic solutions நம்ம எடுத்தோம் அப்படின்னா c வந்து equal to cos theta 1, so 1 plus 2 is cos theta 2 plus theta 2. So from the equations 1, x is equal to L1 c1 plus L1 c1 plus 2, y is equal to L1 s1 plus L2 sin plus 2. So theta 1 is equal to theta 1 plus 2. So 1 square plus 2 square a plus b double square plus 2ab. Similarly, a square plus b square plus 2ab is equal to 2. When you are simplifying this, so the unknown parameter is to be as equal. So we'll be finding the value of cos. So cos of a plus or minus b வந்து பார்த்தோம்னா so cos a cos b minus sin a sin b plus sin cos a sin b plus or minus cos b sin b. So இதுல இருந்து we can able to find out the value of an x, what is the value of y, what is the value of c1, y1, s1. So இதுல இருந்து எல்லாமே substitute பண்ணி we can able to determine the value of an theta 1. Okay. So if you have any further clarifications that I can do. The next thing we have to see about an robot motion plan. Okay, so that we can see it.